So, rate of change of the radius with respect to time. Not r prime. How did we say the rate of change of volume with respect to time? What did we say? dv over dt. What does d represent? The derivative. So I'm looking for dr over dt. So this is I'm looking for the derivative of r with respect to time. Okay? So now, let's talk about this equation that I have. We already decided that I can't just take the derivative of it, because if I take the derivative of it, I get dv over dr, which is v prime, which is an issue, because that's what I'm looking for. What do we say we want to differentiate this with respect to? Time. Is time anywhere in here?
No.
No. So what we're going to do is we're going to differentiate this implicitly. We're going to differentiate this implicitly with respect to time. So, the derivative of v is literally what? Times dv dt, because I'm taking it with respect to time, and time is nowhere in there. So that's this. Because you all told me the derivative of v was dv over dr. In this case, it's dv over dt. So I do it like I do implicit. The 4/3 pi are hanging out. This is 3r squared. But I took it with respect to time, but time is nowhere in here. So you know what that r gets? Now, could you have skipped the red and simplified and gone straight to the black? The answer is yes. So what's happening is in related rates, when you are differentiating, every variable gets its own. d blank over dt. Every variable is going to have a d whatever over dt. So if you have an x and a y and a z in your equation, you're going to have a dx dt, a dy dt, and a dz dt. Because you're taking it with respect to time, and time is nowhere in my equation. Okay? I have a question for you. Do I know anything for this? From my equation, is there anything? What is dv dt? 5 centimeters cubed per second. So I'm going to put my 5 here. What was I looking for again? Can I solve for dr dt? How? So dr dt is going to be 5 over 4 pi r squared. But the question is, do you know what r is? They give it to us, right? To the next. Okay, so 1 centimeter and 10 centimeters. So, when r equals 1, five over 4 pi, yes? Everyone agree with that?
Yes.
Yeah, I know. There's something slightly wrong.
Plus C.
Ah, units! Brandon, what'd you say? Is it centimeters per second, or centimeters per second squared, or centimeters cubed per second?
Centimeters cubed. Oh no, centimeters.
Okay, so let's talk. When I hear centimeters cubed, you think of what?
Volume.
Volume. When I hear centimeters squared, I think of
Area.
area. Is either one of these?
No.
Nope. When I think of radius, I think of centimeters. Why would we be centimeters per second? Because it's with respect to time. And I told you it's per second in the piece above. My volume was 5 centimeters cubed per second. Alright, so when the radius is 1, I'm at 4 over 5 pi centimeters per second. How about when the radius is 10? question. When your radius is only 1 centimeter versus your radius being 10 centimeters, which one is faster for this rate of change? 1 centimeter. Would that make sense as to why? Your volume is growing at the same rate, but think about it, as you get bigger, you have more volume per increase, and I've got less, yes, tinier to travel. That's for lack of a better word. Alright. So let's talk about the next one. And the next one says, suppose we're pouring water into a glass. I'm pouring water into this glass. The question is, as I fill it up, what changes? The volume changes, yes? Okay. So the volume changes. Okay. So the question is, and it says I'm filling it up at a rate of 3 centimeters cubed per second. What does that talk about?
The rate.
The rate of the volume. So I know that dV dt is 3 centimeters cubed per second. I also know what? Oh, the equation for a cylinder. Do we know the equation for a cylinder?
No.
Yeah.
I have a question. How do you find any volume formula?
Length times width times height.
Length times width times height. Do you know where length times width comes
Ooh.
from?
Could be.
The area of the base. So it's the base times the height. It's the base area times the height.
2 pi r squared.
2 pi r squared or pi r squared?
Is 2. So 2.
Base area times the height. It's not surface area. Pi r squared times my height. Pi r squared h. So what am I looking for? What does it say I'm looking for?
The height. Wait.
The height. Am I looking for the height or the rate of the height? Oh. So I'm looking for dh dt. Let's talk about differentiating this. I have a question for you. How many variables are sitting here?
2,
3.
There are 3 variables here. They are R, H, and V. So let's talk about differentiating. The left-hand side is pretty easy. What's the derivative of V? 1 dV dt. I don't care if you write the 1 or not. That's your choice. I'll write it so you know that. Let me take the derivative of V. What happens here? Product rule. Because you have R and H sitting right next to each other, which means that's product rule. Now I'm going to take the pi and put it with R squared, or you can put the pi on the outside, it does not really matter. So I always say first times the derivative of the second. What's the derivative of H?
E H over dt.
Plus the second times the derivative of the first.
Wait. 2 pi.
2 pi r times dr over dt. Remember, every variable has to have one because I'm taking it with respect to time, and time is nowhere in here. We're used to just taking with respect to x. X is sitting there. That's not an issue. I don't have x's, nor do I have time in any of these. So let's talk about simplifying this. I'm just going to get rid of parentheses. So dv dt equals pi r squared dh dt plus 2 pi r h dr dt. I don't care if you write it 2 pi r h or if you write it h times 2 pi r, it doesn't really matter. I just tend to put the constants in front of the variables behind it. 2 pi hr, because this is all multiplication, so it doesn't matter. So I am looking for dV. I have dVdt. I am looking for dHdt. Yes? But I also have this drdt sitting here. No? So I have a question for you. If I talk about a normal glass, what does R represent? Radius. Is what? Julian says the radius isn't changing. Do you agree with him? A normal glass, the radius is not changing. Well, the radius is not changing.
I don't like sitting here.
That's all the hand.
They went to the right.
You gotta be quicker than that.
Get them.
Go ahead and close it. You do know.
They went up.
They'll probably just go up the stairs.
Okay, back over here.
What?
So for a normal glass, if we're just talking about a glass, then the radius is not changing, which means that drdt is 0, which means that this whole piece is going where?
Down the drain.
It's going away. It's going away, right? This entire piece is going away. So I'm literally just going to talk about this piece then. Now, could I have a cylinder that changes this way? Yes. If the cylinder changes this way, then is the radius changing?
No.
It wasn't. I sprinted up the stairs.
I think we got the stairs.
What?
Cassie, did you see it?
No, I heard them like giggling, but they were so fast.
Okay.
They have to be like, I don't know, like ninth graders because they were fast. Slippery. Was it just to spite us?
Yeah.
Like, I can't go to school yet.
So I get your attention back.
No, but I saw
So when the radius isn't changing, all I care about is this formula. Now, I'll tell you if it's a cylinder that, if it's a glass, you can assume that the radius is not changing. If the radius is changing, then I have to tell you something about that. I can tell you the radius is changing at a rate of blank, right? And then you know that you're going to have a drdt in there. So it all depends on how much information I give you. If it's changing this way. So, oh, so now,
Wait, how do you
excuse me, Zach just said, what'd you say, Zach?
you replace
Oh. So I was given dVdt, so he's like, let's replace that. Oh. Hey, can you solve for dHdt?
Yes, ma'am.
You have to do something.
Did I tell you anything else? Then I'm done. Now I have a question for you. If I didn't know that it's a normal glass, well, if it's not, if I know that it could be expanding this way, I had dVdt equaling pi r squared a dHdt plus 2 pi rh drdt. Can you still solve for dHdt? No. Can I still solve for dHdt?
Just subtract the
Yes.
2 pi.
Yes, write this down. So I would subtract this whole piece, yeah? So dVdt minus 2 pi rh dHdt, or drdt, equals pi r squared dHdt. And then what?
Divide by 4.
Yep. So dVdt minus 2 pi rh drdt over pi r squared equals dh dt. Yes.
Would the units for that, would that just be a centimeters per second?
Yep. Yep. So the units for both of these would be centimeters per second, yes. Because that's what I went up. Hey, what was the units for the radius changing? It would still be centimeters per second, right? Because the height and radius are still measured in that centimeters. All right. So let's talk about the next one. Oh, so let's talk about